All right, this is our last one for day one. We have another type of cardioid, so you might need to stop here just to fill it in, but we have one more example where the ratio of A to B is between 0 and 1. And this is what's going to create a limacon with an inner loop. And before you get too worried, we're just going to do the top two. I'll let you try the bottom two on your own and then check it against the answer key online. When you're sketching a limacon with an inner loop, some of you might have missed the pickup here, but I also have this other sheet that I passed out on the day of notes, and it's got a nice summary of all our polar curves. Circles are actually at the bottom here. We talked about that. We're going to talk about lemniscates, and we're going to talk about roses tomorrow in the next set of notes. But here's our examples of our cardioids. So you have your true cardioid. We've talked about the dimpled limacons. The one that we skipped over was a convex limacon, so make sure you check that one out on the note set. But we have this one right here, and if you notice, there's a tiny little loop on the inside, and we're going to talk about how to graph those. How you know that you'll have an inner loop is when the ratio of A to B is somewhere between your 0 and your 1. So let's talk about what this looks like. Overall, it's still a cardioid, so the rules are exactly the same. In terms of symmetry, there's nothing different than on the first page. It's a cosine function, so I will have symmetry over the polar axis. Right? What I would notice is that when I take the constant over that scalar multiplier, I get a half, and a half is between 0 and 1. That's what tells me that I'm going to have this limacon with inner loop. And the rules are the same because it is a type of cardioid. I want to focus on A plus B, and I want to focus on the difference. We're going to say the absolute value of A minus B because sometimes it might trip you up a little bit depending on which one's bigger. But here in this problem, right, A plus B would be 3. I'm just focusing on the fact that it's a 1 and a 2, not the negative. And A minus B, the difference between them would be a 1. And just like with the cardioid, I know that the larger portion of my function, it's going to be centered on the x-axis because it's a cosine, and the larger half will be on the negative side of that x-axis. So I want to plot that 3 on the negative half. And I also want my inner loop. So the inner loop is going to end on the same side as that bulk, that heavier portion. So I'm going to plot my 1 right here. Now, what those points really correspond to are that when I plug in a 0, cosine of 0 is 1. So I would get 1 minus 2. So that negative 1 is actually the 0 angle. And the 3 is coming to you from being in the direction of pi. Plug in pi and you will get a 3 for that particular coordinate. And also, I know the A value is 1. And so just like with the cardioids, on the non-symmetric axis, I'm going to plot that A value. And to get the rest of it, I want to start plotting some points. Remember, I started at theta equals 0, and that puts me right here, sort of on the inside of my inner loop. And I'm going to plug in values like pi over 6 and pi over 4. So let's try it out and see what happens. We get 1, let's see, we'll delete that, 1 minus 2 cosine, and let's try pi over 6. So when I plug in pi over 6, I get about a negative 0.7. So that means that although I'm going in the direction of pi over 6, I'm actually going to graph backwards towards 7 pi over 6, a little less than 1 unit. Let's do it again with pi over 4, minus 2 cosine pi over 4. So around a half, right? Negative 0.4. But again, I'm not going to graph towards pi over 4 because the value was negative. That's going to put me like right about here. And pi over 3, 1 minus 2 cosine of pi divided by 3. I type it in my calculator, I get a 0. So in the direction of pi over 3, I am at the pole. And if I think about connecting those dots, right, I would have a little sort of tiny half circle. Now that little tiny half circle is going to plot itself again. It's going to reflect to the top half because of my symmetry. So let's keep going. At pi over 2, right, I would have plotted to here. So remember, I started by drawing from 0 and I'm wrapping around. And so I'm coming back something like that. When I plug in a pi over 3, I'm going to get 1 minus 2 cosine of 2, sorry, that should be a 2 pi over 3. I just hit the wrong button. 2 pi divided by 3. I get a 2. So in that direction, I'm going out 2 units. If I think about connecting my dots, it's looking something like that. If I did 3 pi over 4, I will get about 2.4, so around halfway. And if I plugged in 5 pi over 6, I'm at about 2.7. So I'm going to wrap like that. And then I still need to reflect all those coordinates, so that 2.7 is going to reflect down to here. And this one would be right about here. And that one was at 2, right? And so it wraps around something. It would go through 0 again, and it would look something like that. So these take a little practice to get a good idea. We'll try one more together. Okay, let's think about what this one would look like, right? It's a sine function. So I know that it would be symmetric over theta equals pi over 2. The ratio from a to b is a half. So again, this is another limacon with an inner loop. And I would have a plus b equal to 3. And the difference between a and b, it's really what I'm interested in, it would be 1. The difference this time, though, is that I have a positive sign. So I want that 3 to graph onto the y-axis with a positive sign, or the theta equals pi over 2. I'm kind of working between them. And then the inner loop, again, would be right at 1. So the sort of tail end of the inner loop would be right here, and the bigger end of my limacon would be up at 3. And I can plot some points, right? Oh, I have one more thing, right? A is 1. And in this case, the off axis would be in the x direction. So I'll plot my 1 and my 1. So let's start at the bottom. Remember, with a sine function, I want to graph this half. So if I plug in something like a negative pi over 2, that is what's giving me my end of my inner loop. And negative pi over 3, I'll use my calculator to help me out. Right, I have 1 plus 2 times the sine of negative pi over 3. That's giving me about negative 0.7. You see it off in the shadows there. Move this over just a little to help with the lighting. And so in that direction, negative pi over 3, but it's a negative 0.7, so it's going backwards. It would plot right about here. Negative pi over 4. It's hard to keep everything on the screen here. Negative pi over 4. I'm going about negative 0.4. So I'm going towards negative pi over 4, but the opposite direction and only about halfway, a little less than half. And then if I do, let's see, negative pi over 6, 1 plus 2 sine negative pi over 6, that's going to put me at 0. So that is what's creating my inner loop right here. We've already plotted at 0, right? At 0, that's what's sending me here to the 1. So now I'll use some of those positive values to plot my coordinates. So at pi over 6, 1 plus 2 sine over 6, that's 2. Pi over 4 is going to give me 2.4, so a little less than halfway. Pi over 3, I've got about 2.7. And if I were plugging in pi over 2, that is what would be putting me at this 3 right here. So my curve is going something like that. I'm going to take advantage of symmetry so that I can stop typing things into my calculator, and I'm just going to reflect the pi over 3 over to here, the pi over 4 over to there. Pi over 6 would reflect onto the 2 on that side, and I can start to curve this thing around, right? It would go through the 0 again, and it would finish like that. So that's how you generate the inner loops. Again, I don't want to finish this. It would take a very long time. I think I got a little too many examples on my new notes sheet here. But try them on your own real quick, and I will post the finished version of the written notes here onto our website. We are going to spend a whole other day taking care of the last 2 pages, so tune in for those notes as well. Look for the links on our course website.